In this video, we will learn about the characteristic properties of upthrust or buoyant force. So the important characteristics for upthrust or buoyant force acting on an object immersed in a fluid are as follows. First is the upthrust or buoyant force exerted by a fluid on an object is directly proportional to the volume of immersed part of the object in the fluid, which means that if the object is halfway immersed, so only this much portion which is immersed volume will be calculated, not the complete volume. Now, it means that if the volume of a given object immersed in a fluid increases, the magnitude of upward buoyant force also proportionately increases. The upthrust on an object is maximum when it is completely immersed in a fluid. Second is the upthrust or buoyant force exerted by a fluid on an object is directly proportional to the density of the fluid. Now, the higher is the density of the fluid, higher is the upthrust force being exerted by it on an immersed object. For example, if an object is completely immersed first into water and subsequently into the kerosene oil, it is observed that the upward buoyant force is more due to water than due to kerosene. It is because density of water is more than the density of kerosene oil. Now, the upthrust or buoyant force is independent of the nature of object immersed, which means that the magnitude of buoyant force due to a given fluid is independent of the nature of the object immersed in it. Now, if we take two balls of the same size, one rubber and another wooden ball, then if both these balls are immersed completely in a fluid, let's say water, the buoyant force acting on them due to the given fluid are found to be exactly the same. It is because their volumes are equal. Fourth is that the upthrust, that is buoyant force, acts on immersed object in vertically upward direction at the center of buoyancy. Now, the buoyant force acts on the immersed object in vertically upward direction and at the point B, which is known as center of buoyancy. Mostly, not all the times, the center of buoyancy is equal to the center of gravity of that particular object as well. In fact, it is the center of gravity of the fluid displaced by the immersed part of the given object. When an object is completely immersed in liquid, the center of buoyancy B exactly coincides with the center of gravity G of the immersed object as shown in this particular figure. However, if an object is partially immersed in liquid, the center of buoyancy B lies below the center of gravity G of the immersed liquid as shown in this particular figure A, and there is no case in which the center of buoyancy is above the center of gravity. Okay, now why does the object float or sink when placed on a surface of a fluid? Now, to find the answer of this question, let us consider the force acting on an object when placed on the surface of a liquid, let's say water. Now, the following two forces are acting on it, that is W, that is the weight force, that is mg of the object acting vertically downwards, and the buoyant force Fb acting vertically upwards, whose magnitude is equal to the weight of the fluid displaced. Now, depending on the magnitude of these forces, there are three situations which are possible. First is the weight is greater than the buoyant force. In this particular situation, the net force acting on the object is in downward direction. That means the object will sink in the given fluid as shown in this particular figure. For example, an iron nail, a metal cylinder, or a ball, or a stone, or a glass stopper sink in water. Second would be that weight is equal to buoyant force. In this particular situation, the net force acting on the object is zero. It means that it will neither sink nor float but remain fully immersed inside the fluid just below its surface as shown in this particular figure. Now, for example, a plastic bottle or a mug filled with water remains immersed in water. Third can be that the W weight is less than the buoyant force. In this particular situation, the net force acting on the object acts in upward direction and the object floats as shown in this particular figure. Now, in this situation, only a part of the object remains immersed in the fluid such that the weight of the fluid displaced by the immersed part of the object just balances its weight. For example, a cork, a wooden block, and a wax piece, when dropped on water surface, they float. Okay, I hope this topic is clear to you. Thank you.